What questions did you have? It could be questions as to why the answer was what the answer was, whether or not the answer key was correct, whether or not your answer might have also been correct. Starting in the multiple choice, any questions on 1 or 2? Any questions on 3, 4, or 5? We're okay on all the multiple choice? Okay. Number 6, any questions that you want to go over on number 6? Okay. Any questions on number 7, the answers or the justifications? Right.
Just a general question.
Yeah.
Do you have to write out the entire final answer number? Or can I write the same way? Like I wrote the equation that would get that number, but I never actually multiplied it out. Like where do
Okay.
I
On like C, on total costs.
Yeah, B and C.
Okay. So for B, if you wrote something to do with f of t equals 78 or f of t minus 78 equals 0, you could get like a point, but you had to actually figure out either the intersections if you did y1, y2, or if you did this minus that is 0, it would scale this all down to zeros. Either way, you had to find both those times for B. Without those decimals, you wouldn't have gotten full points. Does that make sense? And then for C, you needed to use these bounds. Now, guys, did you notice, and this is something the AP loves to do, and it actually saves you time, and it corresponds to something in your calculator. What do you see that they did for the bounds? A to B. What? Oh, they stowed. They stowed this one as A. They stowed this one as B. Why am I saying stowed and not stored? What button is there on your calculator that lets you stow away a number as a variable? Get out your calculator real quick. Let's say you had an answer. Let's say you had a number in your calculator. What button lets you stow it? Why am I saying stow and not store, even though the idea is store? Stow. Stow.
I wanted to know more about 7.
Oh, thank you. It's okay. Let me talk about 6. Thanks, Ryan. Let me go to 7. But first of all, sorry, you guys saw A's and B's multiple times in these free response, right? Stow. What am I talking about? Where is it? Far right? Right above on. Stow. If you hit the stow button, you can stow away a numeric value as an A, as a B, as a C, as a D. Why is that nice? Because then if you found an answer in one step, you could stow it and use it over and over and over however many times you needed, like we use Y1 and Y2. So when the AP does this A and B, what they're doing is number 1, saving time, and number 2, even though they're rounding it up here, they're stowing the entire thing as A, the entire thing as B to avoid as much error as possible and to be able to use it. Someone came in yesterday and said, hey, if I name something A in one part, can I use that A in another part? Yeah, definitely, because you defined who A was or who B was. So just like you saw them be able to write it quickly. It was kind of nice. Sorry, Ryan was asking about number 7, though. Number 7 had to do with the amusement park. Was that what number 7 was? Here he is. Letter B. Ryan, sadly, since this is a calculator problem, and they didn't say write an expression but don't solve, sometimes they do that. Sometimes they say something to the effect of write an expression but don't solve. But this one says how many dollars? You had to solve it. So even though you wrote this out, you probably would have gotten 1 of the points, maybe even 2 of the points, but without actually solving it. Did it say to the nearest dollar? How many dollars? I would have put the cents. I think since it said how many dollars specifically, I think that's why this guy went ahead and rounded it. I would have given that full answer, put a dollar sign on it, and been like, you're not taking points away from me today. But either way, you had to get the numeric answer. And then for part C, you were saying the same thing. C was a bit more complicated. I mean, the point of the problem was that you knew how to find h of 17 and how to find h prime. So if you're thinking like sticking it to the man, this isn't sticking it to the man. This is starting the problem. You have to finish it, especially when you have a calculator. They're expecting you to finish it to a decimal answer. Does that make sense? Non-calculator, you still wouldn't stop here if they asked you for an answer, but you could have actually solved, I mean, not these ones because they're really nasty, but if this was a non-calculator, this would have been, E would have been easier, L, oh, it's both E, sorry. You would have anti-derived by hand, plugged in 17 f of b minus plugged in 9. You could have, once you had all the numbers, you could have boxed it and not simplified it down to make a nice answer. But calculator, you're not doing that anyway. You're just plugging and chugging it. So get the numeric answer. Does that answer your question? Good. Anything else on number 7? Any clarification on any of the parts that you guys want to hear or see? Whether or not your justification was good, etc. Okay, really quickly in letter D for this one. In letter D, when it said, when will there be or where will there be a maximum? Let me see if I like his description. Closed interval test. He went ahead, basically did absolute extrema, where he tested the endpoints and the critical numbers. You had to somehow show that you were testing the different candidates. And the different candidates were at one endpoint, at the other endpoint, and they found the one. He stowed it as A. See? He's just giving a quick little description. But also testing at the critical number. Somehow you had to show testing the endpoints and the critical numbers. You could have used words. You could have shown the math. But if you did not test the endpoints and the critical numbers, you would not have gotten full points, even if you got the right answer. Number 8. Do we have any questions on number 8? For runner A, runner B. Yeah, AJ. Okay, so for letter C, total distance, you have an equation for B and you have an equation for A, right? Except B, you're literally, hold on, isn't there a forever card for total distance traveled? It's the integral from A to B of the absolute value V of t dt. So that was probably pretty easy for B, right, runner B? For runner A, total distance traveled, you have to do the exact same thing, but we don't have an equation, we have a graph. Everybody help us out. How do we think about the integral of the absolute value looking at a graph with geometric shapes? Area. Perfect. Good job, David. Now, AJ, if some of this was below the graph, absolute value would make me take any negative area and make it positive. But what do you notice about all the area? Yeah, so I don't even have to worry about the total distance absolute value thing. I'm still going to write that as my integral expression because that's what total distance is, but I get to just go ahead and say, sweet, I have a in my head, I have a triangle, I have a rectangle. So much easier than thinking trapezoid in my head. So I would find the area of the triangle, I would find the area of the rectangle because they said specifically total distance traveled over the entire time interval, right? So I'm finding all of the area. And it just says find the total distance of both. And so when you look at the answer key for 8D, ¿dónde está? Aquí. Weird. They should have put, I think they noticed that the velocity was always positive. They should have put, he should have put absolute value bars. It wouldn't have made a difference because the velocities are always positive for both, but still. You should have gone ahead and put absolute value. Ryan, here's a perfect example though. In this one, you did not have to get to 85. You could have stopped at 1/2 10 plus 7 times 10. Or if you had done triangle, rectangle, you could have gone ahead and done, sorry, wrong one. You could have done 1/2 base times height plus base times height and just boxed it. That's okay. That's sticking it to the man. Does that make sense? But you would have had to, after this expression, put meters. And then this one was just plugging and chugging to your calculator. And once again, you guys should have put absolute value. So if you were just looking at the answer key, go ahead and add in absolute value bars because it should have been absolute value for total distance traveled. Anything else on number 8? Number 9? Any clarification that we need? Having to do with the particle moving along the x-axis. Number 10, any clarification that we need? Oh, number 9, AJ, which part? Oh, when you were actually looking at the graph. The nice thing is this was a calculator problem. So for letter A, you were literally able just to use your grapher, but somehow you would have had to sketch it, you would have had to figure out where the graph hits the axis. And so where the graph hits the axis, you would have used the 0 function, right? Second trace 0, left bound, right bound, and you would have gotten 3.1415926, which you needed to recognize was pi. Well, when you do, you have to somehow label what these different intersections are. And so if you saw 3.1415926, they assumed that you would know that's pi. Does that make sense? So I mean, you didn't have to solve this by hand. Add 1, take ln of both sides, and then divide by 2 sine of. Like, it technically is unit circle, because you could set this equal to 0, and then by adding 1, taking ln, dividing by 2, you get sine equals 0 when? Pi and 2 pi and 3 pi and 4 pi. But if you used your calculator, you need to be able to recognize 3.1415926, 6.28, I don't know the decimals, blah, 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 then be like, oh, it's going by pies. So you could have solved by hand up here, or theoretically, you could have seen the decimals down there. But pi, 2 pi, 3 pi, 4 pi, and the rest of the problem was good besides the pies. I mean, theoretically, technically, they only require a degree of accuracy of 3 decimal places. So as long as you were using like 3.1415926, technically, I don't think they would have necessarily taken off points, but I mean, it's going to take more time to use those long decimals than, and they'd probably be like, why didn't you see that was pi? I don't think they would have taken points off, but it's always good to recognize pi if you can. Anything else on number 9? Okay, number 10, sorry. We're almost there. 10 was that non-geometric-y dude having to do with the cars turning left, going straight, putting in the traffic signal. Number 11. B, D, and Thomas. C. Okay. So on number 11, C and D, let's check out what the actual questions were first of all. This is the one where you're given a table. The table are people. Ah ha 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 ha. Oh, okay, I was thinking this was 12. The fewest number of times L prime must equal 0. Oh, here's the whole MBT, IBT. His answer on number 11, yeah. ¿Dónde está? It's really long, but my hint in class was you have to use MBT and IBT. So he's totally in line with what I did. And what he does, if you guys notice, he shows one specific example. Look at your table, 176, 156, between 1 and 3, and then between 3 and 4. He shows one specific example. He explains what that means, and then he applies the general idea in 3 total intervals. So he does one specific, and then he goes ahead and from that one specific, explaining it all the way through, he generalizes for the rest. So let me show you the one specific and how he generalized it. I just wanted you to see his approach, though. He didn't have to do a specific, like long drawn out for every single interval. He was specific, very specific for one, and then he went ahead and said, oh, by similar logic or similar arguments, I can say there are this many zeros. So what is he doing? He's looking at this table up at the very, very top. If I can get there. There we go. And they're asking how many times L prime must equal 0. So, by roles, which is on your MBT card, if any of these were to match perfectly, any L of B's equal any L of A's, then I would know that my MBT theorem of L of B minus, let me see if I can actually just put this on top real quick. And I need a little tiny marker. There we go. Uh-oh, it's all shimmery. Stop shimmering. Ah. Oh, well. Remember, MBT says L prime of T is equal to L of B minus L of A all over B minus A. If these two equaled each other, then I would have equals 0. That's what Rolls says. If those two equal each other, then I would have L prime equals 0. That's even worse. There we go. However, none of these equal each other, right? So I couldn't use Rolls. I couldn't use just MBT. But what I can do, even though I can't say any of those equal, so I can't say that's 0, I still can say MBT applies because of this little condition right down here, twice differentiable function. If it's differentiable, if it, meaning L, is differentiable, that means he's also continuous, so MBT applies. And since he's differentiable, thus continuous, MBT applies. I know this is true on any single interval. So what I was saying the other day is, on average, MBT says the average rate is going to have to equal the instantaneous rate at least once. So on average, do you guys see how there was an increase from here to here? On average, there's an increase here to here. Okay, if all I know between 0 and 3 is that on average it increased here, and here. That's all I know. I have no idea if it decreased. So it could be strictly going up, and never have had a 0. So I know nothing about 0 to 3. However, between 1 and 4, average increase, average decrease. See it? If it on average increased between 1 and 3 and on average decreased between 3 and 4, that means there had to be an instantaneous that was positive at least once here and an instantaneous that was negative at least once there. And by IVT, if the function is differentiable, the derivative is continuous. That means, well, if you had a positive derivative and a negative derivative, by IVT, what had to happen somewhere in between? Positive to negative, there had to be a 0. So let's look at his rationale. He used this 1 and 4, and he actually did the numbers and said, hey, look, from 1 to 3, on average, there was a positive rate, aka MVT says, see, L prime had to be positive somewhere here. And then from 3 to 4, on average, there was a negative rate. Therefore, by MVT, L prime had to be negative there. Since L prime is continuous, that's all by that differentiable clue right here. Oops, sorry, my line got moved. Differentiable, that means the derivative exists. Since L prime is continuous because of that differentiable clue, by IVT, a sign change means there must have been a 0. So he just said, hey, look, because I saw a change in average increase to average decrease, MVT says the derivative had to be positive, then negative. IVT says the derivative is 0. If he spent his time on one interval, there has to be 1 0 here to here. Then all he has to do is say, sweet, by similar arguments, let me go look at my table. By similar arguments, how many more times does this happen? Well, by similar arguments, we saw the average increase to decrease, decrease to increase. Hey, there's going to be one more. Increase to decrease. Hey, there's going to be one more. So he got, there's one change here, there's one change here, and there's one change here. Increase to decrease, decrease to increase, increase to decrease. So 3 total by similar arguments. Similar arguments, there's 1 here, and he already showed the 1 here. So 1 and 2 and 3 total. Does that make sense? He could have gone super detailed on all 3 of them, but he just went super detailed on 1 and said, similarly, yay, here and here as well. 3 total. And then, C and D. Oh, D is a nice one. Because D, as far as like the work, because D just asks for, if we give you an equation for rate, tickets per hour, how do we get back to tickets from tickets per hour, guys? Integral. But some of you got confused because you saw the at or the by, and you thought it was only one time. And so you might have thought it was some sort of integration as net change dealio. However, it wasn't integration as net change, because what you were needing to think of, the tickets didn't go on sale until what time? No. When did the tickets go on sale? At noon, which was t equals 0. So if the tickets didn't even go on sale until noon, well, there weren't any tickets sold at noon. Noon is when everything opened and people were able to get in and start buying tickets. So 0, there weren't any tickets on sale. So it's saying, hey, how many tickets were sold in the first 3 hours, basically, between noon and 3? So you just had to do a definite integral of r to t dt equals, and then label it with tickets. And it says to the nearest whole number just because they only want whole number tickets. Does that make sense, AJ? Cool. Number 12, and then we're done. Biscuits and tea. Anything biscuits and tea? Too bad it wasn't crumpets. Yeah, AJ. Nope. You're okay. Anybody else? Number 12? All right, make sure your name is on it. Pass it up, pass it over, pass it in. Slope field notes. Remember today, the majority of today is examples. I had this on the board, sorry. Let me freeze the screen. I had this on the board yesterday. Some of you guys took a picture of it. Some of you guys did not. Our goal for today is pretty much as many examples as possible. Our goal for today pretty much is as many examples as possible to help you with your worksheet. If you can finish that worksheet tonight, you are going to be doing awesome. Did I miss any integration as net change packet as I go around the room? If you guys can't tell, What's starting to be turned in up here?
Yeah.
Technically due this February, give a week of grace. So I'm going to leave them up here until next Friday, yeah? But you guys will be getting new stamp sheets next week. All right, cool kids. So integration has not changed. There we go. Huh? Yeah, honors pre-count. They were supposed to, they had like 15 minutes at the end of class to just make up a message and then make up an encoder, make sure that someone could decipher, like have an inverse, and then give it to a friend and see if they could decode it. And I think only like one person got one done. It was kind of sad. It's like, oh. You're like, yeah, buddy. It depends on the classes. Honors had different ones than regular. This year I haven't figured out what messages I want to hide. What did I do one year? I think I did May the Force be with you and then may the odds be ever in your favor. That was a few years ago. It was applicable at the time. I don't know what else. Some poor kids would be like, what? I don't know what word that is. Not everyone's seen Mary Poppins. That'd be so sad. Okay. Just in case. I can't even talk. Just in case, differential equation, remember whenever you see that, it's either dy dx or y prime. You can put it different ways, dy dx or y prime. Solution functions could be general or could be specific. Usually specific, but they're going to be y equals. Remember the y equals, those are talking about the flow or flowing through. Differential equations, those are talking about the slopes. That was a big one. I said at the end, you guys saw me pull up Wolfram Alpha and be like, okay, it could give you more detail, but they aren't going to be calculator questions anyway. Or if they are in a calculator portion, it's going to be one of those where it's going to be matching it in a way where you can't really plug anything in your calculator anyway. My tricks that I was talking about yesterday are look for the flat lines if you're given a slope field. Look for the flat lines if you're given a slope field, because the slope field are the flat lines are when the slopes are 0. So what would make each differential equation 0? That can be a trick. Is there anything in common along the x-axis? Because that's always when y is 0. If you plug in 0 in an equation, will something stay the same or will something change? Same thing along the y-axis. Is there anything that's the same or anything similar? So when you plug in x equals 0. Are the slopes parallel vertically? So it's only in terms of x. Are the slopes parallel horizontally? So it mean the differential equation only in terms of y. And then last but not least, this is kind of like your if worse comes to worse. Quite literally, if worse comes to worse and nothing else is working, because to be honest, more recently I've seen them give very, very similar differential equations with a graph where there's only one little baby difference. Not like totally different. One's exponential, one's trigonometric, one's logarithmic, one's rational, one's like, they're so similar. If worse comes to worse, then I would say, first of all, look at quadrants and be like, oh, hey, that one, quadrant 1 is always positive. Which one, if I had a positive x, positive y, would always be positive? Or quadrant 1 is negative. Which of these positive x, positive y would always be negative? Sometimes you can tell by quadrants because the whole quadrant has sloped up or the whole quadrant has sloped down. But as soon as your quadrants are partially up, partially down, you're going to have to start going to individual points if nothing else has worked. We were working yesterday. I think you guys finished off with what? Example 7? Yeah, but we didn't get to talk about example 8. So let's zoom in on this page real quick. I think we matched number 7. Did you guys have any questions? Sorry, I didn't really get to ask. I think we just matched it real fast. You saw my parallel horizontal, so I got to go to the y guy. You saw my parallel vertical lines. I got to go to the one with x. The diagonals we saw yesterday is usually like a plus or minus sort of dude. What I didn't get to talk about yesterday was some of you guys might have were little tick marks, and I guess depending on the example, they could just be little tick marks. And it's along the y-axis, which is when x equals 0. So when x equals 0, the slope is 0? Oh, hey, that makes sense. Plug in 0, the whole thing is 0. Everywhere except for 0 over 0, which is undefined, and yeah, there's... And can you guys tell if you follow the flow? Let's say we established a point. If you follow the flow, it's flat up here on the axis, and it's flat down here when it comes back to the axis. But what's the slope over here on the x-axis? What's the slope? Not horizontal, but vertical. And wouldn't you have a vertical slope when y equals 0, right? Because anything over 0 is undefined. So sometimes they actually show you those straight up and down lines, and sometimes it's like follow the flow. Yeah, it would be a vertical line. So anyway, that's kind of like when x equals 0 along the y-axis, when y equals 0 along the x-axis. Something you can tell. Number 8. Did you guys get to play with this one yesterday? Okay. I think also if we keep on going, we get to questions that have limits, and some of you in homework, did you notice there were limits, x approaching infinity, x approaching negative infinity? Okay, so you might want to grab out, well, everyone, grab out your homework spirals with your colored pens to be ready. But we're going to get in our note packets to a limit one. Talk about that first, then we'll go check homework, okay? So let me give you a second to open up homework and get it ready. But we're going to go get to some limit problems in our notes packets and then go talk about homework and see if that clarifies things. Okay? All right, example number 8 says, the slope field for a differential equation is shown at right. Which statement is true for all solutions of the differential equation? Solutions, hold on. Solutions. Are solutions the slantiness of the slopes, or are solutions the flow? Okay, good. So right away, whenever we see solutions, remember, we're thinking about the, why are ads coming up on my computer? There's some setting that I was, and now random things are coming up. Okay. Flow. So for Roman numeral 1, the reason I asked that is because, look, solutions are decreasing, aka flow is decreasing. So for x less than 0, x less than 0, does that mean as you go to the left, to the right, up or down? If x is less than 0, left, good. X's are negative and going more negative. So for x's being negative, is the flow decreasing? Because x negative is over here to the left, right? Are some flows decreasing? But if you have a different initial point, what are other flows doing? Oh, okay. So that's not true for all, right? It's not true for everybody to the left, for all negative x values. Okay. How about number 2? All solutions level off near the x-axis. Any particular point you choose? Here, levels off. Here, levels off. Here, levels off. Level off means get flatter and flatter. Level off means getting flatter and flatter. Yeah, that's true. No matter what initial point you choose. Careful, careful, careful. It says true. They could say false in a different problem. And we could get it totally opposite. But yeah, all solutions level off. That's true. For all y greater than 0. Okay, if y is greater than 0, am I talking about from 0, 0 to the right, to the left, up, or down? Up. Good. Y greater than 0, positive y's is up. Everything in the first and second quadrants. All solutions are increasing. Are all the flows increasing if you pick any point above? Yeah. So therefore, final answer would be D, 2 and 3. Does that make sense? I can't say to the left, because to the left for x less than 0, sometimes going up, sometimes going down. So if you were trying to match this with a differential equation, I would need when y equals 0 to be giving me zeros, when y is positive to only have positives, when y is negative to only have negatives. But if x is positive, sometimes negative. When x is negative, sometimes positive, sometimes negative. Now, they didn't give us differential equations. I'm not going to make you come up with one, but those are all things that you could think about. I want you guys to go to examples 9 and 10. Do you see any limits in here? Yeah. Ooh, I do. Number 10. So let's talk about number 9 really quickly. Then let's talk about number 10, and let's go to homework. Sorry, I'm trying to open up homework so we can be ready for it. Number 10, I want you guys to take a second because most of you haven't looked at it yet. It's a matching question. They give us a slope field, and they're asking, when will this slope field of this differential equation have vertical segments? Have vertical segments. Turn in your groups real fast. Vertical segments. What does that mean about the slope? Vertical. Go. Then think about the equation. Vertical. Then try to put it together as a group. Vertical means what slope? So which one would have that kind of slope? Nation, what? Why is that up? Why is that up? Okay, what'd you guys figure out? Vertical means what? Oh. Undefined. So, if they're undefined, where? Numerator or denominator? We have a fraction. Where's the 0 have to happen? Denominator, good, because it has to be undefined. So what do I know? I know 4x plus 2y has to equal 0. Now, the AP has super weird ways of asking this. It can say something like, what's the relationship, or what is true, or what's the characteristic? And literally, it's just saying, oh, hey, this is true. I mean, specifically, they want to know y is equal to subtracting 4x dividing by 2, negative 2x. Anytime that is true, my denominator will be 0, and my tangent lines will be vertical. Oh, hey, there it is. Let it be. My denominator would be 0, which will occur when y equals negative 2x, and I will always have vertical tangents. So I will have vertical tangents along a diagonal line. Okay, now number 10. Let's talk about these limits. They are giving me different clues, but not specifically saying y of 0 or the initial value equals 0, but if y of 0 is greater than 0. So they're saying, hey, what if this is true for the clue? Or what if this is true for the clue? Or what if this is true for the clue? Hold on, let's review. If we have a clue, does that mean we follow the flow? Right? Okay, so if y of 0, when x is 0, y is positive. If x is 0 and y is positive, okay, anywhere up here. If I were to choose any of these as my point and then follow the flow, okay, and follow the flow, what would be going on as x goes to infinity? Would the y's be going to 0? I don't think so. Aren't the y's going to infinity? If you choose any of these as your initial points, that's going up. It's not going to 0. Hold on. And it's saying true, right? True. Okay, yeah, no, that's false. Okay, what if y of 0 is in between 0 and negative 2? Okay, when x is 0, y is in between. Okay, so what if we choose any of these points as our initial and follow the flow? Do you guys see how it'd be like a weird cubic function kind of, but like flipped? Sorry, cubed root function. One of those weird like swoopy swoop ones. Because you could like swoop down here-ish and like swoop up here-ish. Seems to be like a couple horizontal tangent lines or something. Sorry, horizontal asymptotes. That one would swoop up, so that's why we knew that was false. What's going on here? The limit as x goes to infinity, which means to the right, right? Are the y's going to negative 2? Yeah, sure looks like it. Isn't it leveling off, seemingly to negative 2? That's a true. Okay, how about the last one? If y of 0 is less than negative 2, so something down here. Follow the flow. Ish, right? Does the limit seem to be 0? I don't think it can get up to 0. Isn't it getting closer and closer to -2 also? It's going to be like steep, but then somehow it levels off. Okay, no. It's going to -2. False. So the only one would be 2 only. Let's go look at homework. Because you guys had some limits in homework. Okay. I have the evens. They're ready to go. But can you guys help me out with... Here, it's Hangaya. Crocs and everything. Patricia, the end of class to Richmond. Okay. Where did limits show up? Just because that's like fresh on our heads, we just looked at limits. Where did limits show up? Wasn't it second page? 57? Okay. Let's go peek at 57-ish. There he is. Yeah. Actually, did you guys have 55? Or 56? No? Oh, all right, never mind. So 57-ish, because this one had some limits too. See a little x going to infinity? Ooh, stop. So you'd be looking to the right, what's going on, to the right, what's going on. Okay. 57 says, sketch the slope field for the differential equation. Aw, they didn't give me points. So what would you have had to do? Either use Wolfram Alpha and try to sketch whatever, but Wolfram Alpha does so many little slash marks it would take forever. So instead, yeah, kind of make your own, but where would you need to make it? What's your initial condition? Bless you, the 0.42. So you would somehow have to include the 0.42. I think if I were you and I was having to do something like this, there we go. Just because some of you were like, I don't even know how to make my own slope field. I think I would have probably looked at this guy and seen, okay, it's -x plus 3. I need 3 and 4, 2. So if I was to go here and here, I think I would go up 1, 2, 3, 4, 5. I think I would just do first quadrant if I could help it, because that way I get my little first point, which is 3. I can go up 1 over 1. 1, 2, 3, 4, 1, 2. I need to be able to sketch this guy. Maybe you wouldn't have had to go up quite so far. There we go. But somehow you have to include the 0.42. So you would have had to at least have a few points around it to be able to follow the flow. So maybe I would do these points-ish. I might not do any more just because I'm hoping this will be enough. I don't have to go in any other quadrants, but I think I probably would have done each of these points. You can make a grid system out of the whole shebang. But which one did you have, guys? Number 57, is that the one I'm looking at? Okay. If you went ahead and did your slope field, I'm just going to go ahead and start doing slopes because it's going to be annoying to do all my little dots. We could say at 0, 0, oh, everything's dependent on x. Sweet. So if I plug in 0, everything is going to be 3. So up 3 over 1 is going to be pretty steep. Pretty steep. Parallel, pretty steep, pretty steep, pretty steep. When x equals 1, everything's going to be 2. So up 2 over 1. So not quite as steep. Not quite as steep. Not quite as steep. Not quite as steep. At 2, everything's going to be 1. So still less steep. Less steep, less steep, less steep. At 3, everything's going to be 0. 0, 0, 0, 0. At 4, everything's going to be -1. So going down 1, down 1, down 1, down 1. At 5, everything's going to be going down 2. Oops, that's way too steep. Down 2, down 2, down 2, down 2, and then down 3, down 3, down 3. Okay, but we can still kind of see the flow, can't we, guys? So if we were to take this guy, well, he's on the downhill slope, but somehow he has to even out. Okay, somehow it's going to be like this, right? Ish. And it says, discuss the solution as x goes to positive infinity. Well, that means going to the right, right? And then to negative infinity, that means going to the left. What does this guy seem to be doing to the right and to the left? Just think of the limit. Yeah, so then I probably would have answered this something to the effect of, for number 57, the limit as x goes to negative infinity of my, well, if this is y prime, couldn't I just say of y? And the limit as x goes to positive infinity of y, both seem to be negative, oops, sorry, negative infinity. Does that kind of make sense? But is that what every slope field shows? No. Sometimes it'll be going up. Sometimes it'll be going to like some weird horizontal asymptote thing. I don't know. But this one, both were going down. Okay. Were there any other odds you guys had questions on? And maybe you figured out 57. Sorry if you already knew that one. But any questions on odds? Remember, you can have your worksheet out and be playing with it if you don't have homework questions. Any more odds? Ale. Oh, it's even? Yeah, Michael. 25, Ruth? 39, Thomas? Okay, let's look at 25 first and then 39. So 25, we're just doing odds before we check the evens. 25 looked weird, but actually he was meant to be easy. So let's just pay attention to the directions. Oh, little focus box, go away. Thank you. The directions say some of the curves corresponding to different values of C are shown in the graph. Find the particular solution that passes through the point. Here's the crazy thing. They're not telling you to solve for anything as far as differential to original, because what have they already given you as the original? They gave you the general solution. So when they ask for the particular solution, guys, this is like your chapter 4A test, where it said, given a point, solve the initial value problem, but you don't have to go find them. They already gave them to you. Literally all you need to do is say, okay, what is this such that or for the point 0, 3? Well, 3 is y. X is 0. You were just supposed to do 3 is equal to c, e to the, well, that's just 0. Anything is 1, so 3 equals c times 1. They just wanted you to say, oh, hey, that must be c equals 3. That's the equation for that guy. Yeah, I know. It was so easy. It was hard. They already told you this is the general solution, so we're going to make it particular. And if you have the general, plug and chug to get C, you're done. So following the flow at a point is like finding the C. I'm going to freeze the screen because a couple of you are still looking at that. But then the next one was number 49. Is that right, Ruth? 39. Thank you. He's on the next page. Okay. 39 was a very different section, meaning we didn't really practice number 39 in our notes, so that could have made it a little bit rough. Its directions were use integration. So you were actually supposed to be using integration antiderivatives, probably because there are no bounds, to find the general solution, aka with the C. So for number 39, wait, I can't integrate right now. It's not legal yet, is it? But what can I do to both sides in order to make it legal to integrate? Who am I going to move? Move the dx. As soon as I can multiply the dx to the other side, is this ready for an integral? Yes. So you haven't seen this a lot. We're going to see it more in section 5.2, 5.3. But as long as we, or as soon as we split up that dx in any of these problems, because they're all in terms of x, we can go ahead and integrate. Now, integrating 1 dy just gets us y equals. If it was something else, we'd have to integrate something else, but integral of 1 is just the variable. And over here, do you guys remember what we're going to have to do first? Rearrange, rewrite, or I would say divide. You can either do long division, or in this one, since it's simple, can't we just divide? Or make this x to the negative 1 and distribute? X to the negative 1 and distribute, or if you divide, you get 1 minus 2 over x, which is the integral of 1 dx, minus 2 times the integral of 1 over x dx. We should know this guy is x, and who's this guy? ln. We get your plus c. That is your general solution. And I guess the back of the book could definitely have made this go up. We've had something like either y equals x minus ln of x squared, because you don't need the absolute value as soon as it's squared, always positive. Or they could have also written it y equals x minus. They could have moved the negative 1 up also. ln x to the negative 2 would be ln of 1 over. Either of these would have also been okay. But yeah, does that make sense? Cool. All right. Any other odds? Going once, going twice? Okay, evens. Kiddos, I know this is going to go fast. So we're going to go over questions on the evens tomorrow and questions on the worksheet, what you've been able to try. Oh, stink, stink, stink. I'm just going to scroll through the evens right now. Why? What can you do tonight? Grade the evens from the YouTube video. Remember, class resources link in Google Classroom. You don't have to go looking for this. But I'm going to scroll through the evens so you guys can check out the evens tonight. Come with questions tomorrow. I have number 30 showing, number 38 showing, number 48 showing. You guys can go ahead and go. 52 is C, 54 is A. $90, D is the final answer. Just talking to myself, aka you, later on. Hi, future yous. Final answer. You could have gotten a decimal, or you could have just left it like this. I would have just stopped right there. And then we're done. So guys, if you need to, go ahead and go back and pause at whatever evens you needed to grade or you needed to check. And then come tomorrow with questions. Bye. Okay, bye guys.